Hello and welcome to another exciting edition of Physics Videos. This video is the second video of the series. Today we will be talking about section 10.2 from the book, which deals with rigid objects under constant angular acceleration. This concept is very similar to the one we dealt with in chapter 2. The difference being in chapter 10 we will be dealing with constant accelerations in an angular motion. In other words, rotational motion. An example of this kind of motion would be a CD, which rotates about a fixed axis and has a constant angular acceleration. In addition, the kinematic expressions for the rigid object under constant angular acceleration are of the same mathematical form as those for the particle under constant acceleration found in chapter 2. Notice here the four equations for a particle under constant acceleration translated for a rigid object under constant angular acceleration. Notice how each equation is the same exact equation except for the symbols used. Instead of x for angular position, instead of x for position, theta is used for angular position. Instead of v for velocity, omega is used for angular speed. And instead of a for acceleration, alpha is used for angular acceleration. Another important thing to note is the units we assign to angular position. Since angular position is just a number, we have to assign some kind of unit to it. We use radians. 1 radian is the angle subtended by an arc length equal to the radius of the arc. 1 radian is approximately equal to 60 degrees. The problem I will be working out today is number 13 from the book. A spinning wheel is slowed down by a brake, giving a constant angular acceleration of negative 5.6 radians per second squared. During a 4.2 second time interval, the wheel rotates 62.4 radians. What is the angular speed of the wheel at the end of the 4.2 second interval? To begin with, we determine that the formula we use is the second one, which states that the final angular position is equal to the initial angular position plus the initial velocity, angular velocity, times the time, plus 1/2 angular acceleration t squared. We then plug in what we know. So we know angular position initial equals 0. T equals 4.2 seconds. And the velocity acceleration is 5.6. And that is all equal to 62.4 radians. We want to solve for the angular speed, so we separate omega from the rest of the equation. This is what we get here. Then we plug in all the numbers, and in conclusion we get 3.1 radians per second. Hope you enjoyed the video. This is Joey DeRossi signing out.